So yeah, this is just so nice that I can have the last session on the last day of this 2-week workshop. So that's super cool. And yeah, I'm excited to talk about the Gurobi OptiMods. So what is why OptiMods? And I guess in the past 2 weeks, you've learned that um, all those different concepts in this field can sometimes feel like there's this 10-ton weight being dropped on you, and you should be proficient in maths and modeling and programming and data science. And it's just all so much, and there are so many different things you probably don't know yet and still need somehow. And this is basically where Gurobi OptiMods should come in. Um, so what are OptiMods? Maybe as a first disclaimer, the name is completely made up. So don't interpret anything into the name. It's a made up name. I can tell you later some of the other ideas we had for the projects. This is the better one. So the idea is each OptiMod solves one single specific problem. So like those tools here, they take input data in some what you might consider natural form, and also return solutions in a natural form. So a data in, data out concept. And it's all Python, so they're nicely integrated into the existing Python ecosystem. Um, it's all based on Gurobi Pi, but it also uses Pandas, SciPy, NumPy, NetworkX, all those fancy Python packages. And yeah, basically, an OptiMod solves a specific optimization problem using Gurobi without explicit modeling. So we've just seen in Pavel's talk that, yeah, the modeling part can also be tough. So it's supposed to cut this part out. And the nice thing is they're extensively and nicely documented. So you should always find what you're looking for and how to use every single mod, because this is one of the, let's say, uh, contribution requirements. So if you want to contribute a new OptiMod, it should have a nice documentation. It should be nicely readable. So then are OptiMods the solution to all your problems? Well, unfortunately not, because this simplicity always comes at a price. And of course, you don't have all the flexibility of a full modeling language or just Gurobi Pi in general if you want to use a more simple problem or a simple approach. But it certainly comes in handy when you want to look at a common optimization problem. For instance, maximum bipartite matching, line optimization, maximum flow, min cut, minimum cost flow. And we have a bunch of those. And I just invite you to go to this webpage, Gurobi Optimods. .readthedocs.io. This is where the documentation lives, or you can just find this on our public GitHub space, the Gurobi GitHub space. So it's just like github.com/Gurobi. And well, you can really just install it with pip install Gurobi Optimods. And assuming your data is in a suitable form, you just put your data in and run the mod and look at your output and look at the result. So let's have a look at a demo for min cost flow. I'm pretty sure that this problem is known to everyone here in this room. You just have a network and vertices, edges, and you have costs and capacities on those edges, and then you want to route a flow through this network to fulfill a certain demand without exceeding the capacity and trying to minimize the costs. So let's see how this looks in code. So we have a bunch of predefined data sets that contain example data. So you can basically like start right away using those OptiMods with those example data sets. And here we just have edge data and node data that we just get from this data sets module that is included with the OptiMods. So this is what it looks like. These are just two pandas data frames, right? So there's capacity and cost for those edges, and there's demands on the nodes. And yeah, this basically defines your network. And then all you really do is you import the OptiMod that you that you need. So in this case, it would be the min cost flow OptiMod. This is in the second line. And then you take your data, edge data, node data, and just call the min cost flow pandas function from the min cost flow OptiMod. And here you can print the objective and the solution. The solution is basically the flow through this network. And here we also added a small visualization. So this is basically all you need to do. And now you solve the min cost flow problem without having to think about the formulation or the model step. You really just have to have your data in the suitable format. That also just makes sense, right? How else would you format your data for a min cost flow problem? And then you can run the mod. So, but now let's look at maybe a bit of more involved demo, line optimization for public transport networks. So here you want to come up with the cheapest I guess cheapest in sense of operational cost line plan that satisfies your demand in a certain city or network where you have like certain public transport lines operating at certain costs. So there's a setup cost and an operational cost for all those, I don't say, maybe buses or subways or trains. Doesn't really matter. So again, in data sets, there is a data set for this OptiMod as a starter example. And that's the Sioux Falls network data. This is just a common public transport example. So it has been used in several papers and it's kind of popular. So there's a node data table that has the X and Y positions. There's an edge data table that defines between which nodes there is a connection, how long this is, and how much time it takes to traverse this edge. There is a line data that defines like what kind of lines do we have operating in this network and how expensive they are or what their capacity is for transporting passengers. And there's also a line path describing where those lines actually go through the network. And finally, we have demand data that just specifies where our passengers actually want to go, from which node to which node. So correct me if I'm wrong, but I guess this is like fairly standard. This is how you would come up with a data set for a public transport network line optimization problem, right? And yeah, this is then all you have to do. You just call line optimization from the line optimization OptiMod and put in all your data and run it. In the background, the model will be built, all the variables and constraints will be added. The data is fed into the model, and you run Gurobi to solve the problem. And here in this OptiMod, we even include a line plotting functionality to just make it a bit more nice. So you can put in your node data, edge data, line path data, and the solution, final lines, was computed by the OptiMod. And then you get this nice network plan that actually visualizes what your optimal transportation or line plan should look like. And another somewhat related OptiMod is the metro map optimization. I just find this super cool. So this is, does anyone realize or recognize this one? I hope so. So that's the Berlin subway network. And I mean, you know those octilinear graph representations, right? Where you basically have 8 directions from one node to the next. This is just like commonplace for all those train network plans, but it can be tough to get this, right? There are different ways of how you can represent the physical node coordinates in this kind of representation. Yeah, and there are different objective functions, and this is all included in this OptiMod. So you can also play around with this and basically put in your geographical data of the nodes and connections and lines, and then get a nice octilinear graph representation. So that's pretty cool. So let me conclude about for this technical part of my presentation. That's the yeah, basically a short summary. So the OptiMods provide data-driven APIs to solve common optimization problems. So Timo in the past asked me like, okay, how is this different from just an example code? And yeah, basically these are full-fledged APIs. So you can think of those as examples with batteries included. And I think this is also a great way to make optimization more accessible because yes, you still need your data somehow. I don't really know how we can get around this problem, but now at least here you don't need to know about the model. So the model step is cut out for you. And if you also want to contribute, this is a great way to yeah, I don't know, have some fun and do something in the open source world. We also have a bunch of other open source Python projects. So this is mostly, yeah, I guess all of our open source endeavors are with Python, just because this is just the most popular one and everyone at Gurobi just likes to work with Python mostly. And what I specifically want to mention here is the Gurobi log tools package. So maybe for your master's thesis or even PhD thesis, you might want to parse Gurobi logs. If that does not sound super outlandish to you, I very much recommend you to check out this project, this module, because it will do it for you. It will just parse how many log files you have and present the data in a pandas data frame in a much more easy way to process this for data analysis or visualization. And this is just much nicer than just looking at a bunch of log files say manually or yeah, with the bare eyes. There's also a nice project for machine learning extension, where you can plug in a trained machine learning model into an optimization problem. So that's also something that we have heard in the past days from other people. And Gurobi Model Analyzer is also somewhat nice. So this can compute some numerical features of LPs, like condition numbers, and tries to give you some kind of reasoning or explanation of why you might see numerical issues in your model when you solve it. So yeah, again, get involved and share your feedback and ideas. And now I want to go over to like this, yeah, maybe just presenting Gurobi as a company or what we do at Gurobi. So it's about 170 people all around the world, all working remotely from their homes. And I've just heard this in the session before, in the coffee break. Um, you're a solver company, so everyone at Gurobi needs to somehow be involved with the solver, right? No, actually not. So you see here from this pie chart down there, it's basically like 1/3 of the company is actually the tech team that is involved with the solver, that has some math OR background, that is developing the solver, working on the product directly. And the rest, the other 2/3, are doing other things like sales and marketing, finance, HR, or just operations and IT. This is sometimes what people forget, because they see, oh, Gurobi is like just doing this solver, just a bunch of people sitting in their homes together and hacking away on the solver code. No, there's actually way more. And I think but the most interesting part for you, of course, is the tech team. So this is comprised of the experts, the dev, and the TAM team. TAM stands for Technical Account Manager. Um, yeah, these business terms, they're somewhat exchangeable. In some other companies, this may be called pre-sales. So these are people who have also a math or programming tech background and try to come up with prototypes and convince people that Gurobi is the right tool for them. So they come into play before the customer is actually a customer, when he's still a prospect, and they might consider getting into Gurobi. The experts team is where I'm working in, and we provide support for the customers and the users. And this basically means all kinds of support. This can be like simple installation issues where someone just doesn't find the right file or doesn't know where to click, but this is pretty rare. Up to something that is more in the realm of consulting, actually. So where we get model formulation questions or parameter tuning requests. And then, of course, there's the dev team, which is, well, developing the solver. So this is both the engine dev team, really developing the solver directly, and also the platform dev team that is working on our cloud solutions, all the architecture things, and those things we have around the core solver. And as you can see, there's also a nice almost third-ish distribution, which is quite nice. So these are around 60 people, just to give you some ballpark number. The tech team is about 50 to 60 people. Yeah, and then I want to talk a bit more about the experts team. So as I said, yeah, we're supporting all our users around the clock and also drive innovation, because we're not just, I mean, this is not a customer support call center or something where we're on the phone constantly. Most interaction with customers happens via tickets, so text-based, asynchronously, and we have time to respond to those questions. And they're also usually not time critical. Having said that, we usually still reply within half an hour or an hour or so people really like this. So yeah, we're pretty proud of the support that we actually can provide. And I guess our customers are also pretty happy about this. And what is really nice, I only realized this when I made this slide, is that we have 7 people in each of the time zone regions. So in North America, there are 7 people. In Europe, there are 7 people. And in Japan and Australia, there are also 7 people. So it's also quite nice. And I want to share one recent success story to give you a short, very, very brief insight into what we do. So there's a customer, opens a ticket and asks for parameter tuning. This is a fairly regular request. Happens about once or twice a day that such tickets come in, maybe also 5, maybe nothing in like 3 days. And they say, well, they have a 5% gap in 30 minutes when they just run Gurobi default settings on their machines. The goal is, well, yeah, 1% gap in 10 minutes, that would be great. 1% gap in 30 minutes would still be okay. And 5% in 5 minutes would also be super helpful to be able to debug the model more quickly and get a nice solution or a somewhat okay solution very quickly. And then you can maybe abort the run or something like this. Then, yeah, what did we do? We just kicked off an automatic parameter tuning run that ran for about 35 hours on 12 machines on our data center and our cluster. And it provided parameters that bring the gap down to 2% in 30 minutes. So yeah, it's not exactly what the customer wanted to, but it's still good enough, I guess. Well, and then Simran looked at the model and actually provided a reformulation idea. So there were a bunch of indicator constraints, and she realized that you can actually write them in a different way. And then the gap was 0.03% in 60 seconds. And this is just super cool. And this happens all the time. And this is also the reason why our customers are so super happy. So raw performance is really good and very helpful. Without this nice solver, you couldn't do that much either. But then you should not forget about the mathematics behind it. These really just make the difference. So you can have the fastest solver and the largest machine, but if your model is just not modeled in a way that that fits the solver or that is the most efficient way, then you're going to lose out on performance. And yeah, maybe a word about our customers. So many customers have a strong OR or math background. Actually, some of the participants here are our customers. So Jakob, for instance, from SAP. So we basically engage with the subject matter experts of the specific company. So these are like basically our peers, which is also very, very nice. Yes, there are also some less tech-savvy customers every once in a while who just can't get something installed or set up. But then again, they're also super helpful when they receive our help, and we basically solve the problem they have been struggling with for 2 weeks or so. And since, I don't know, maybe 2 years or so, we sent a quick survey after every ticket, just asking whether they liked our support or whether they have something to complain. And yeah, this has never been below 98% of positive replies, which is just super nice. So every month we aggregate the data and look at the results, and this is just super cool. And yeah, having happy customers actually also makes our work much more pleasant. And yeah, so I'm asking, like, how are you going to start your journey in the tech team? Maybe as a TAM, if you're more into developing prototypes and convincing customers that Gurobi is the right way or the right tool for them, or in the dev team when you want to really go into the nitty-gritty of the solver and try to a hardcore programmer, or maybe as in the experts team if you really enjoy helping people like I do. Yeah, thanks.